Hi friends, today we are discussing a problem based on coplanar concurrent forces. So let me read the question here. The following forces act at a point 20 Newton inclined at 30 degree towards north of east. So this is north and this is east. So from east towards the north it is 30 degree it is given. So 30 degree towards north of east. So east is there and the north of east 30 degree. This is 20 Newton given to us friends. This one. And the second force we have got 25 newtons towards north, which is this one, and 30 newton towards northwest. So if you see this, 30 newton is acting towards northwest, so it is 45 degree. And the fourth force is 35 newton inclined at 40 degree towards south of west. So we'll take west and then south of west is this. So 40 degrees towards south of west, the force is 35 newton. Okay. So we have got a system of coplanar concurrent forces. All of these forces are passing through the same common point. Okay. And we have to find the magnitude of resultant force as well as the direction of resultant force. So let's find out the magnitude of resultant force as well as direction of the resultant force. So we need to find the magnitude of resultant force as well as the direction of the resultant force. So to find magnitude of the resultant force and direction of resultant force, we will be resolving each and every forces along x and y direction. So let me call this direction as x direction and the vertical direction is y direction. And we'll be resolving each forces along x and y direction. So let me take this force. I'm going to start from here friends. So I've got four forces friends, F1, F2, F3 and F4. So the F1 is this force, that is 20 newtons. The force F2 is 25 newton. Force F3 is 30 newton and the force F4 is 35 newton. So now we shall be resolving these forces along x and y direction. So for resolution of forces friends, so we can resolve it like this: along x direction, this one along y direction. So each force will be resolved like this. This force is acting vertically upward direction, so it has only y component. There is no x component for the force F2. Now similarly force F3 also will resolve like this. So F3 will also have x component and y component, and F4 also will have x and y component. So now if you look at this angle friends, this angle is 30 degree. So this angle also will be 30 degrees. So 20 Newton will be resolved along x direction as, so this angle is 30, so it will be 20 cos 30 and the vertical will be 20 sin 30. Okay. So with what angle is made, it will be cos and the other one will be sine. Similarly, if you look at here, this is 45 degrees by geometry. So if it is 45 degree friends, this force 30 will be resolved like this along x direction as 30 cos 45. So similarly, this 30 newtons can be resolved like this along vertical direction or y direction. So this will be 30 sin 45. Now this 35 newton can also be resolved. So this angle is 40 friends. So this will be 40 degrees by geometry. So 35. So since the angle is over here, so this will be cos. So 35 cos 40 degrees. This will be sin 35 sin 40 degrees. Okay. So what I have done basically, I have resolved all the forces along x and y direction by considering proper angles. Okay, so where angle is made, that component is cos. You can see this angle is made over here 45, so it is cos. Here this angle is 40, so it is cos. Okay, another angle is sine. Okay, so like that I am able to resolve all the forces, that is this one, this one, this one. The vertical force 25 Newton is in the vertical direction, so it has only y component. So I'm going to write down all these forces. F1 20 Newton, so F1 got resolved along x direction as 20 cos 30 and along y direction 20 sin 30. You have to be careful here because since it is acting towards right, so it is positive. Okay, and it is acting towards up, so it is positive. Okay, so this also you have to take into the consideration. Now if you look at here 45 friends, now this 25 is acting in the upward direction, so upward is positive, only y component is there, so there is no x component, so only y component here, so that is going to be positive friends, so positive 25 newtons. Now 30, if you see 30, it has this component towards x direction, but it is negative, towards left side is negative friends, so it is going to come minus 30 cos 45, and y component it is in upward, so it is positive friends, so plus 30 sin 45 degrees. Now so we got component of this also. Now the last one is 35, it is acting downward and it is acting towards the left, so towards left is negative and downward is also negative friends, so x component is 35 cos 40 but negative. So minus 35 cos 40 negative, and y component is also negative, so minus 35 sin 40. So now we have to find out the summation of all these values. So here we have to get the summation of all the quantities. So you'll be getting here summation of fx, and here you'll be getting summation of fy. So if you add these quantities, you'll be getting summation of fx and summation of fy. So this value, if you do addition of all this, you'll be getting minus 30.70 newtons, and if you add all these values, you'll be getting minus 33.7 minus 33.7272 newtons. Okay, so we got summation of f of x as minus 30.70 and the summation of f of y as minus 33.72. Now we have to find first, that is the magnitude of resultant force. So the magnitude of resultant force is given by, you can say, Fr, which I am going to consider as a resultant force, and that is square root of summation of f of x plus summation of f of y square. So already we have calculated the value of summation of f of x and f of y. So if you substitute that value, you will be getting minus 30.70 square plus minus 33.72 square, and if you solve this, you will be getting resultant value as 45.7. so you will be getting resultant force as 45.70 newtons. So friends, this is how we have got the resultant of the given system of forces. So this is the magnitude of resultant force, friends. Now we have to also find the direction of resultant force. When we calculate the direction of resultant force, basically we are looking for angle made by resultant with the positive direction of x-axis. So what is the direction of resultant force? It is basically an angle theta made by resultant, made by Fr, the resultant force, with x-axis. Okay, means positive direction of x-axis I am referring here. This value we are looking for. So it is given by, basically theta is given by tan inverse of summation of fy divided by summation of fx. So that value is going to come as tan inverse of fy is, summation of fy is minus 33.70, while summation of fx is minus 30.70. This is 72 basically, 33.72. So this, if you solve, the value of theta you will be getting as 47.68 degrees. Now here you have to be careful that summation of f of x is also negative and summation of f of y is also negative. It means both the coordinate of the Fr, resultant force, are negative. So it is going to come in this quadrant, that is called a third quadrant, because here both f of x and f of y are negative. So the angle is going to be something like this, friends. It is going to be like this. This is resultant Fr, right? And this angle is 48 point. Okay, so angle made with the negative direction of x-axis. So this is how we can calculate the direction of the resultant. Okay, so this is, we got the direction of resultant, and this is the magnitude of resultant. The same procedure can be adopted to find the magnitude and the resultant of the given system of coplanar concurrent forces. Okay, thank you very much.